Hello, greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Ladies and gentlemen, tonight I want to take you through probability for grade 10. So the focus is for grade 10 learners. Kindly relax and hope you'll enjoy the session. All right, without wasting time, guys, don't forget to go through my YouTube channel, which is at Kangaroo Maths and Science and Academy. And don't forget to like, subscribe, and hit the bell button for future video notification, right? Let's now start with the probability for grade 10. Right, here is the learning outcomes, which I'll take you through each of them. Number one, at the end of the session, a learner must be able to actually define the term probability. So you need to be able to define what is probability. You need to also familiarize yourself with definitions such as sample space, sample size, events, and also give examples of these terminologies. And you must also be able to know the notation and also how to calculate probabilities. And again, you must know the rules of probability, particularly for grade 10, we'll talk about the complementary rule and addition rule. And you must also be able to know the conditions for mutually exclusive events, which we will talk about. Then also you need to be able to construct and understand a Venn diagram in terms of probability, but it can be in terms of probability or just the counting, but I will take you through everything here. I believe you are well, right. Without wasting time, let's now start with the definitions let's start with the probability session, right? Okay. Now I will first take you through the definition of probability. Now let's now start with the definitions. Number one, you need to be able to know what is probability. Right. Number one, probability is defined as the likelihood, or you can say is the chance of an event to occur. The likelihood or the chance of an event to occur is called the probability. So the chances or the likelihood of an event to occur is regarded as the probability. Right, under this section of probability, we need to be able to understand what we mean by a sample space. Let's define the term sample space. A sample space is defined as the set of all possible outcomes. The set of all possible outcomes. It is a set of all possible outcomes. This is called the sample space. A set of all possible outcomes is called the sample space. All right. Then now, we can just say it's a set of all possible outcomes in an experiment. Yes, we can just put it in that way, but it's just defined as the set of all possible outcomes. Then also, you need to be able to familiarize yourself with what you call a sample size. We'll be talking about this. Sample size is the total number of outcomes, or we can just say of observations. in a sample space. So the total number of outcomes or observations in a sample space is regarded as the sample size. So you need to be able to familiarize yourself with these definitions. But I'll explain each one by an example. So we have what you call a sample space, which is the total number of, is a set of all possible outcomes in an experiment. Then we also have sample size, which is the total number of outcomes or the observation in a sample space. So sample space is a set of all possible outcomes in an experiment, whereas sample size is the total number of observations or outcomes in a sample space. Then the last one is the issue of an event. So you need to be able to define what is an event. Right, in terms of event, an event is the subset, an event is the subset of a sample space. A subset of a sample space. So an event is the subset of a sample space. So this is called an event. A subset of a sample space is regarded as an event. And what does this mean when we say is a subset of a sample space? It means that it belongs to the sample space. So if you want an event, you'll find it inside the sample space. So it's part of the sample space actually. So it's part of the sample space. For example, if we say, let's say we are saying we're having event A here as an example. Okay, I apologize. Okay, let me just try to zoom out. So if we say, let's assume we have the event here. Let's call that event A. Okay, let's call this event A. And inside this event A, we have another set or another, yes, let's just call this event A. Then inside the event A, we have another event in it. So let's just call this B. So what does this mean? It means that a B so it means B here, it's a subset of A. So B is a subset of A, which means B belongs to A. So now, when we're in the event of an event, when I'm saying, when we say it's an event is a subset of a sample space, means we can find the event inside the sample space. So that is what is referred by an event in terms of probability. So an event is a subset of a sample space, whereas a sample size is the total number of outcomes or observations in a sample space, whereas a sample space is the set of all possible outcomes in an experiment. Right. In terms of this, what can be able to say, okay, fine. From now on, when we talk about the word sample space, we'll be using a symbol S, which will just denote what you call sample space. So when we talk about sample space, we'll just denote it by an S. We'll talk about that. So now, then also we'll talk about the sample size, and also we'll give examples of an event. Right, without wasting time and without going through the notations of actual how to calculate probability, let's now give examples of what do you mean by a sample space, what do you mean by a sample size, and what is an example of an event. For example, if I say as an example, let's consider a case where we're talking about when one, like, it's just an example. Okay, let me just use a different color. Okay, let me just use black. So let's say as an example, let me just call it example 1. We are having a case where we are rolling a die. Imagine when you are rolling a die. If we are rolling a die, it means on a die, in terms of the outcomes that we can get, the die can have the following set. On a die, we can have 1, 2 as an outcomes, 3, 4, 5, 6. So this is what we can get on a die. So the die has 1, 2, 3, 4 up until size. I'm saying up until 6 in terms of the outcomes. So what does this mean? It means that this is the set of all possible outcomes that we can get on a die. And this set of all possible outcomes, it's referred as the sample space. So this is the sample space. So the set of all possible outcomes in an experiment, it's actually called a sample space. And since we say this is the sample space, now we have to be able to determine the sample size. Remember, I said S represents sample space. So which means if you want to determine the sample size, this will be the number of the sample space. The number this is the sample size. So what is the sample size? From the definition, the sample size is the total number of outcomes or observation in a sample space. Remember, 1, it's an outcome, 2, it's an outcome, 3, 4, like landing at 1, landing at 2, landing at 3. This is just an outcome. So what are the total number of outcomes in this? We have 6 outcomes, which means the sample size. The sample size here will be 6. So 6 is the sample size of rolling a die. I believe you're following. All right. Remember, I said sample size is the total number of outcomes or observation in a sample space. And now, what is an event? An event is just the subset of a sample space. For example, if we say, when we are rolling a die, where we say the die, it has landed on the side on 1. So already for a die to land on 1, it means this is an event. And we can take this event as as a subset of a sample space. So we can either get this from the sample size space. For a die to land on 1, for the die to land on 4, landing on 5, this is just an event. Like when we say in terms of, let's say, it's just an example, it's a different case. Let's say raining tomorrow. When we say raining tomorrow, this is just an event. This is an example of an event. But now we are going to link the event with what you call the probability. For example, if I say, what is the probability of a die to land at 1? I mean to say to land on 1. So we want to talk about the probability of a die to land or landing on 1. You see, landing on 1, this is an event. But now we are incorporating this with probability. So now we are talking about the probability of an event to occur actually. And this landing on 1, we can either get it from our sample space. So now we are able to determine, to give example of a sample size and also a sample space. Another example. Let's do another example. Let's assume, okay, let me call this example 2. This time around, we are tossing a coin. Tossing a coin. Remember, a coin can either have heads or tail, unless if it is biased. Right. It means now on a sample, like on a coin, what would be the sample space? Remember, we said sample space is a set of all possible outcomes. So it means on the coin, we can either get heads or tail. And now, since we say this is the sample size, I'm saying sample space, I apologize, then what will be the sample size? Sample size is the total number of observation or outcomes in a sample space. So it means the sample size there will be 2. So it means this is denoted by the N of S, which is the sample size. I believe you're following. I believe you're following. So there are a lot of examples that I can give that will explain about the sample space and the sample size. All right, let's now continue. So I explained what is the sample space. I explained what is the sample size and what is an event, which is a subset of a sample space. Now, the question is, how do we actually represent these probabilities, or how do we calculate probability of an event? All right, in order to calculate the probability of an event, one must be able to know the notations behind probability. You need to be able to familiarize yourself with notations behind probability. Let me talk about the notations behind probability. Right, how do we actually calculate the probability of an event? Right. When we are calculating probability, there is a way of calculating probability. So I'll just say, when we are determining the probability of an event, probability, I apologize, of an event to occur. This is calculated by, we can denote this as using the P for probability. Then event to occur, let me just call that event E. Okay, let me use a different. Okay, I apologize, guys. Right, so now, right, since I said probability of an event to occur, I want to call this event, let's call this event E. So which means that the probability of the event here, the notation will just write P of E. So the P of E here, this is called the probability of event E. So it means if I just write P of A, this is the probability of event A to occur or occurring. So this is just the notation. For example, if I say P of B, this is the probability of event B to occur or occurring. So now, actually, how do we actually calculate probability? Let me write the definition of calculating probability, ladies and gentlemen. Right. When we are calculating the probability of an event, of any event, I'll just write the formula here and translate it. So if we say apology, if we say probability of event E to occur, it means this will be the number of favorable outcomes of that event let's call this event E. Then we divide by the total number of observation or outcomes in a sample space. And what does this mean? It means that when we are calculating the probability of an event E, we actually look at the number which is the N of the favorable outcomes of that event, which is event E. Let me just use a different color. So event E, the number of favorable outcomes of event E, then now divided by divided by, look at this, total number of outcomes in a sample space. What is this? This is a sample size. So it means you have to divide by the sample size. So this is the same as sample size. So it means this will be the probability of E is the number of those events of E, favorable outcomes of that event E, we divide by the sample size. Remember I said NS is the sample size. So this is how we have to, like, this is the formula for calculating the probability of an event. For example, if I say I wanted to calculate, just an example, the probability of A, it means this will be the number of favorable outcomes of that probability of that A. We divide by the sample size, which is just NS. I believe you're following. For example, probability of B, this will be the number of favorable outcomes of that event B, divided by the sample size of the event B. I believe you are following, ladies and gentlemen. Right. Now, I want to take this further because now we are able to determine the probabilities and when we're able to know how do we calculate probability of an event. Let's go to the example number 1, where we spoke about rolling a die. Remember, we spoke about the sample space when one is rolling a die, that on a die, you can either, when you are rolling it, it can land at 1, it can land at 2, it can land at 3, it can land at 4, it can land at 5, it can land at 6. But now, what if we want to represent this in terms of probabilities? What if we want to represent this in terms of probabilities, ladies and gentlemen? For example, now, if we say, what is the probability of a die to land at 1? So it means now we want P probability of 1, which is P at 1. As our notation, this will be the P of 1, the event of 1, so which means it will be the number of those ones divided by the sample size. We know the sample size, ladies and gentlemen. Right, what is the number of ones in a sample size? It's only 1, but from a total of 6. So it's 1/6. And what is the probability of getting 2? It will be the number of the favorable outcomes of event 2 divided by the sample size, which is still how many 2's are in here? 1/6. What is the probability of landing at 3? Same applies to the number of outcomes of 3 divided by the sample size, which will be 1/6. Same applies 4. It will be the number of the events 4, the outcomes 4 divided by the sample size, which will still be 1/6. Probability of 5, it will still be 1/6. Probability of 6, it will still be 1. You see, they have equal probabilities. But if I say from the same question, what if now I wanted to know what is the probability of a die to land, like actually to have yes, to land on an even numbers. So we want to talk about even numbers here. Okay, right. So what would be the answer here? If we wanted to know what is the probability of a die to land on the even numbers. So now it means we're going to say We want, okay. Let me just use a different one. We want the probability of getting an even number. What would be the probability of getting number, even number? So it means that we count the number of those even numbers, and we divide by the sample size. And from here, how many numbers are even? Remember, even we're referring to 2, 4, 6, 8 numbers that are divisible by 2. So it's only 2, 4, and 6. So it's only 3 out of 6, which is just half. I believe you're following. I strongly believe you're following, ladies and gentlemen. But now, let's now move on to the case of when one is tossing a coin. Okay, let me first erase this. We explained this already. Okay, if one is tossing a coin, ladies and gentlemen, okay. So remember we said earlier that when one is tossing a coin, what would be the sample space? Sample space will be heads and tail. What will be the sample size? Sample size, it will only be 2 outcomes. So now, what is the probability of getting heads? Obviously, it will be the number of those heads divided by the sample size, which will only be 1 out of 2, which is 0.5 if we were to round this. Then like with these other ones, it's 0.173, all of them. Okay? Then now, what is the probability of a coin to land on tail? So it will be the number of the tails divided by the sample size. So how many tails are here? It's only 1 out of 2, which is 0.5. So I believe now you are able to calculate probabilities. You can now calculate probabilities of an event. Okay. Right. Let's now move on. Okay, right. Okay. We went through the definition of probability. We define what is probability as the likelihood or the chance of an event to occur. We define what is the sample size, which is a set of all possible outcomes in a random experiment. The other one, we define what is a sample size. We said a sample size is the total number of outcomes or observation in a sample space. And we define what is an event, which is a subset of a sample space. And we even went through examples of like giving examples of a sample size, a sample space, when one is tossing a coin or rolling a die. So these are the examples. We went through that. But this is the sample size, sample space, and this is the sample size. We went through this. I strongly believe you are following. Right. Now you are now able to represent probability in terms of its notations. You know the notations of probability. Remember, we said the probability of an event E to occur is the number of favorable outcomes of that event E and divide by the sample size, which is the total number of outcomes in a sample space. So we went through this, and I believe you guys are following. Now, without wasting time, let's now continue. Okay, right. Then now, the next one is the issue of rules of probability. So went through this, went through this, went through this. Now we're going to talk about rules of probability. Let's talk about the rules of probability. Number one, I'll talk about the rule of probability that says the probability of any event, the probability of any event should always be between 0 and 1. So probabilities always range between 0 and 1, which means when we are calculating probability, you cannot get probability that is bigger than 1, or you cannot get probability that is less than 0. They will always range between 0 and 1. For example, if you went through where we said the probability of a coin to land on heads, it's only 1 out of 2, which is just 0.5. And the probability of a tail, it's only 1 out of 2, which is, you see that the numbers are ranging between 0 and 1. So you cannot have any probability that is bigger than 1 or less than 0. Another thing, if you went through the issue of a die, probability of a die to land on 1, it's only 1/6, which is roughly 0.17. And you see that 0.17, it's also between 0 and 1. So you need to know the rules of probabilities. Number 2, for grade 10, we have what you call complementary rule. Complementary rule. And I'll also explain this using a Venn diagram. Complementary rule states that the probability of event A plus the probability of not having event A, it's always equals to 1. So the probability of A plus the probability of not A, it's equals to 1. Now, what does this mean? It means the notation, if you do not want to write not A, this can be written as probability of A plus the probability of A with a dash. So this is the same as not A. So it's A or not A. Okay, guys, I apologize. Just a minute. Okay, welcome back, guys. I apologize. Right, as I was saying that here we're dealing with complementary rule, which says the probability of A plus probability of not A should always be equals to 1. So this is all about complementary rule. So it's either we say not A or we write A with a dash. This is the same as not A. So which means that if you want to calculate the probability of A alone, we can transpose the not A to the right-hand side. So this is the same as 1 minus the probability of not A. For example, let's say we are told that probability of A is 0.7. What would be the probability of not A? If you want to use complementary rule. Obvious, the probability of not A will be 0.3. Because 0.7 plus 0.3 add up to 1. It is based on this. Because if you want to prove, you can say the probability of A plus the probability of not A, this should be equal to 1 in terms of complementary rule. So since we know probability of A is 0.7, we can now calculate the probability of not A. So which means we'll transpose the 0.7 to the right-hand side. Then it means the probability of not A, it will be 1 minus 0.7, which will be 0.3. Complementary rule is very important, particularly for all grades, actually, grade 10, 11, and 12. So it's very important to be able to know complementary rule. And we're gonna link this complementary rule with what you call mutually exclusive events. Right? Then now, the other one, which is number 3, is called what is called, it is called addition rule. Right? Addition rules is talking about the union of two events. So usually in this paper, I'll talk about this symbol, this one, which is the same as, it's just referred as a union. Usually it's the same as saying or. And this one, it is an intersection, which is the same as and. Right, so here we'll say, in terms of addition rule, it states that the probability of A or B is the same as taking the probability of A plus probability of B minus the probability of A and B. So probability of A or B equals to probability of A plus probability of B minus probability of A and B. We can even write this as, if you want to use OR, you can use union as A or B equals to the probability of A plus the probability of B minus the probability of A intersection B. So this is one of the most, it's also important for both grade 10 actual to 12. You need to be able to know addition rule. So these are the rules of probability, particularly for grade 10. In grade 10, we only talk about complementary rule and addition rule. But when you go to grade 12, even grade 11, we're going to talk about independent events. So this is relevant, particularly this video is for grade 10. But even the grade 11s and grade 12 can also watch, but they need to, they need to also understand the part of independent events. So, but in grade 11, we're not going to talk about independent events. So just to sum up here, probability of any event always ranges between 0 and 1. 0 being impossible, 1 being certain. And 0.5, it's just likely. The equal chances of an event to occur. Then we also have complementary rule, which states that the probability of event A and not A should always be equal to 1. For example, if I say, what is the probability that tomorrow you'll go to school? Or what is the probability of raining tomorrow? So if I say, what is the, like if I say the probability of raining tomorrow, okay, let me just do this. Raining tomorrow. So the probability of raining tomorrow, let's say it's 0.42. Then I say to you, what would be the probability of not raining tomorrow? So you see now, this is actually the complement, because if we say if we say we let raining tomorrow to be R, which is 0.4742. So it means not raining, it will just be R dash. What would be the answer? Remember I said this must add up to 1. So it would just be 1 minus 0.42. So 1 minus 0.42, this will give us a probability of 0.58. Raining and not raining should add up to 1. These are called complementary rules. Okay? No, just a minute, guys. Okay, let's now continue, guys. So as I was talking about the complementary rules, and also I have what you call the addition rule. This one is very important. That says probability of A or B is equals probability of A plus probability of B minus probability of A and B. Right. Then now, I want us to proceed to the issue of the conditions for mutually exclusive events. But now, before I talk about the mutually exclusive events, let's talk about how to construct a Venn diagram. Right. What is a Venn diagram actually? A Venn diagram is just a way of representing information or representing data, like in terms of probability. But it can also be not in terms of probability. It can be in terms of just the sample size, if we were just, or in terms of the outcomes. But now I want to talk about in the context of probability. Let's say we have two events. I'll just talk about two events for now. So you need to be able to know the complementary rule, the addition rule. Now I want to take it further to the issue of a Venn diagram. So in grade 10, you need to be able to construct a Venn diagram in terms of probability or in terms of the outcomes in a sample space. Now, in terms of probability, if we talk about probability, consider, let's talk about this. Let's say we have, okay, let me just talk about one event for now. If we have one event, let's just call this, yeah, this is just a sample space. And this sample space actually will have the, let's just call it S. Let's call it a sample space. In this sample space, if you want to represent this as a probability, I will say, okay, fine. If we have an event here, consider this. Let's say we have an event here. I'll just call this event A. So if this is event A, let me just put it inside there. If this is my event here, let's call it A. It means that anything that is not in this A, it's actually not A. It's outside. It's here. So it means this shading is shaded area here. It's where we have what? It's where we have the not A. So this is the not A. So this will be A not. Which color should I? Okay, let me just say this will be A not. So this will be A not. It means it's not part of A, it's outside. But now, if we call this as the sample space, in the event of sample like outcomes, it means this must be the sample size. So it means whatever we're talking about here, when we add A and not A, if we're not talking about probability, it means the number of, let me just say, let me just do it like this. The number of A's plus the number of not A should be the sample size. If you're not talking about probability, we're just counting should be the sample size. But what if we want in terms of probability? We know that, for example, if we want probability of A, this will be the number of A's divided by the sample size. And when we want not A, it will be the number of those not A divided by the sample size. So it means if we divide here by the sample size and here by this, because remember what you do on the left, you must also do it on the right. What is this going to give us? This will give us the probability of A, like is this one, and this will give us the probability of not A, and this becomes 1 because they'll divide. You see that we end up having what you call the complementary events. So now it means if we take this further in the event of, like, let's in the case of 2 events, let's say now we have 2 events. Let's call this event A and another event. Let me use a different color. Let's call this event B. If you look on the 2 events, there is a point where the 2 events have intersected. So what does this area called, this one? So this is the area where the 2 events are intersecting. So it means this is called the A and B. So it means A and B are occurring simultaneously or at the same time. So this is A and B. And if this part is the A and B here, how about the remaining parts? Because we need to be able to explain each of that. Now, so it means the A and B is just it's like the occurrence of A and B, like the actually occurring, the event A and B are occurring at the same time. So now, it means if we say, how about this other part, this side? Let me just use a different color. How about this area here? And how about this other part, this side? So you see that at this part here, we only have A. There is no B. B, it's not there. So which means this area here, it's where we call it, we say there is this area, there is A and there is no B. The B is not there. The B it's not there, so it's gonna be B not. So it's A and not B. So it's where we have A and not B. And if we have A and at the same time we do not have B, it's the same as we can just say we have A only. So it's the part where we have A only. But now, how about this side? This side, it means it's where we have B, but A it's not there because A it's just this part, this other part. This is the whole of A. So it means here, it's where we have not A it's not there. A it's not there. Okay, let me just use a blue one. A it's not there. A not. And not or. And B is there. There is A and there is B. There's not A and there is B. A is not there, but there's B. So which is the same as B only. So this is what we have, the B only. But now, how about these other parts? From the same Venn diagram, where we have the event A, the A is still there. And, okay, let me just use the red one. The B, it's also there. Remember, this is A and B. But this time around, I want us to talk about this region here. This one. So this region here, it's a region where we do not have it's neither A. The A is this one, by the way. There is the B. But you see now we're talking about outside of both A and B. So it means this area, this shaded area here, it's where we have, there is no A and there is no B. So it's not A and it's not B. So there is no A and there is no B. So it's neither A nor B. So you need to be able to know this. But how about this part here? How about when we have event A and we have event B with the intersection? Now I want to shade this whole area here. What would be this whole area, this one? Okay. So this whole area here is where we have A or B. It's A or B, not and, it's A or B. So this is where we call this A or B. This area, the whole area here, it's called the A or B. Why or? Because it's where we either have A and B. Remember on this we have A and not B, A and B and B and not A. So which means if we talk about A or B from a Venn diagram, we can look at the case where there is A and there is no B. So I'm adding this area, this part here, with where there is A and B, I'm talking about this with where there is no A and there is B. So it means it's the same as, remember we said where there is A and there is no B is the same as A only. And where there is not A but there is B is the same as B only. So this is our region. But now, remember I said, if we are talking about sample size, if you're talking about probability, it means that this must add up to 1. It means this whole area must add up to 1. And if it's adding up to 1, you see that if we get A or B, this part plus this one. So to get the not A and not B, this other part, we just take 1 and subtract A or B. So we'll talk about this using examples. Right. I want you guys to listen to me. Remember we said this is called an intersection, this part, where we have A and B. And how about this one? This is where we have A only, and this is where we have B only. So if we take the A only with A and B and the B only, it will give us A or B. I believe you're following. I believe you're following. So it's very important for you to be able to understand this. And the last one, it is the issue of mutually exclusive events. And this is very important actually in the paper, guys. Okay, let me address the issue of mutually exclusive events. So events that are mutually exclusive are those events that has no intersection, which means event A and B will be mutually exclusive if the occurrence of if A and B are not occurring at the same time or simultaneously so. So it means a condition for mutually exclusive events. So when we have mutually exclusive events that are mutually exclusive are those events which has no intersection. No intersection, which means they do not intersect at all. There is no intersection. It means they have nothing in common. For example, if I say this is the event A, and there is another event B, you see the two events have not intersected. They have no intersection. Let's say it's A and B. You see, they're not intersecting. There is no, it means the probability of A and B is 0. 0. So it means if the probability of A and B is 0, then two events are mutually exclusive. So which means A is there, B is there. They're not intersecting. Unlike if it's like this. If they intersect, it means they are not mutually exclusive because the probability of A and B this time around is not 0. So this is the conditions for events that are mutually exclusive. Events that are mutually exclusive, the probability of A and B is always 0. They have no intersection, A and B. I'm not talking about or, I'm talking about and. So which means if we have events that are mutually exclusive, if we want to calculate the probability of A or B, remember, according to the formula, we know probability of A or B is probability of A plus probability of B minus probability of A and B. Can even write that as and B. And since they're mutually exclusive, means this becomes 0. So it means just to calculate A or B, we only add A with B because the A and B is 0. I believe you're following, ladies and gentlemen. Now, let's take this further by looking at the examples. Okay. Right. Right. Now let us look at the example here. Number 1, what are we given? We're given the events A and B. Okay, let me use the one from the so that I must not erase time again. Okay, here we are told that okay, we are told that we're told that the okay, I apologize, guys. Okay, we are told that the probability of A what's wrong? So we are told that the probability of A is 0.3. If we wanted to calculate, what if we wanted like what would be the probability of not A? Obviously, this would be 0.7 because this must add up to 1. Okay, I believe you're following. So what is the probability of B? We are given probability of B, it's 0.5. And we are also told that the probability of A or B is 0.6. So the first question says determine the probability of A and B. Remember, we can calculate probability of A and B by using a Venn diagram or by using a formula. All right, let's do this. Let's first use a formula to calculate the probability of A and B. Remember, we are given or, so we're gonna say the probability, this is number A. The probability of A or B equals to the probability of A plus probability of B minus probability of A and B. And what is the probability of A or B? It's given as 0.6. Probability of A, we have it 0.3. What is the probability of B? It's 0.5. Now we can calculate probability of A and B, which is the same as intersection. So here we have 0.6. We can add these two, 0.3 plus 0.5. This gives us 0.8 minus probability of A and B. So we can calculate probability of A and B in two ways. We can move 0.8 to the left-hand side. So this will be 0.6 minus 0.8 equals to negative probability of A and B. So this will give us negative 0.2 equals to negative the probability of A and B. And we can divide both by negative or multiply. So it means the probability of A and B, it's actually 0.6. Say 0.2. So it's 0.2. Now we have 0.2. Okay. Then the second question says, calculate the probability of A and not B. A and not B. Remember, I've told you that you can still construct a Venn diagram. Let's construct a Venn diagram in order to calculate the probabilities. Let's construct a Venn diagram. Right. Here we're having two events. And remember, since the A and B is not zero, it means they are not mutually exclusive because they are intersecting. So I will use, let me use blue and different color. Right, let's say this is A, event A. And another event, okay, let me use this color. This is B, okay, that's fine. It's B. So let's call this B. First of all, we look at the intersection between the two. What is the probability of A and B? Probability of A and B, it's 0.2. Remember, I said this is the intersection, so it's 0.2. It's this one. So this is the probability of A and B. And now, guys, what is the probability of the whole of A? The probability of the whole of A is 0.3. So it means this area here should add up to 0.3. Already we have 0.2 as A and B. So it means from the 0.3, we have to subtract 0.2. Because remember, the whole of this is A. And within this, we have 0.2, it's A and B. So we want this. So it will be, remember this sum to 0.3. So it will be 0.3 minus 0.2, which will be how much? Which will be 0.1. So it means probability of A only, it's 0.1. What is the probability of B? Probability of B, it's 0.5. And within this 0.5, we subtract 0.2 for A and B, then this will give us 0.3. And remember, I said if we take 0.1 plus 0.2 plus 0.3, this will give this A or B, is the A or B, the one I was talking about here. That when we have A, this area here, this A or B, all of this. So that's why if we add 0.1 plus 0.2 plus 0.3, what is the answer? 0.1 plus 0.2 plus 0.3. This gives us 0.6. So you see that is A or B. Now, already you see that this add up to 0.6, but the probability, if it's probability, this must add up to 1. So if the whole has add up to 1, already we use 0.6, because 0.1 plus 0.2 plus 0.4 is 0.6. How much are we in short of to get 0.2? I'm sorry, to get 1. It means it would be 0.4. So what is this 0.4? 0.4 is this outer area where there is no A and B. This is not A and not B. Okay, so now we want to, okay, I wanted to erase this so that we can easily see. Right, even this other part. Okay. So this is our event B. Okay. Then, okay. So then what is the 0.4? 0.4. So this is 0.4 outside. So now look at this. What did I say about? Remember, this is where we have, this is the A and B. So this one we have A and B. And how about this? It's where there is A and there is no B. And how about this? It's where there is no A and there is B. So the same as A only. So because we are calculating probability, then what would be the probability of A and not B? So we want now to calculate the probability of A and not B. Remember, I said this. If I write and or I use this, it's the same thing. Okay? So now, what is the probability of A and not B? So it means this is the same as A only. So it's where we have A only. And what is the A only? 0.1. So this is the answer. Now, how about if we wanted to get, like, how about if we wanted to get the probability of not A and not B? Where there is no A and not B, obviously it will be outside the 2, which will be 0.4. This 0.4, it's not A and not B. I mean, if you wanted to do that. Now, but number C, we are given not A or. You see, now they're talking about or, which means it's an addition rule. What we can do is, let's rewrite the addition rule here because it's or. So it will be probability of A or B equals to probability of A plus probability of B minus probability of A and B. So remember, this is the same as a union. Same as this one thing. And this is the same as this one. But now what do you want? We do not want A or B. We want not A or B. So what does it mean? It means on A, we have to negate that. So this would be, let me just use it. So we want not A or B. According to the question, it's not A or B. So it means we only negate the A throughout. So we negate the A here because we want not A or B. I believe you're following. All right, we want the probability of not A or B. So I will talk about this. Not A or B. It's not A or B. So actually from our Venn diagram, we can just say the not A or B, we're actually restricting A only. So it's 0.2 plus 0.3 plus 0.7. I'm saying 0.4, the neither. But now I wanted to show you in full. So we can say, okay, fine. This can be calculated as, if it's say or, usually you just use an addition rule. So what is the probability of not A? I think I've explained that. Complementary rule. You can even read from the graph. I'm saying from the Venn diagram. Not A 0.5, 0.3. I'm saying a probability of A 0.3. So how about not A? It's 0.7. So let me tell you, we're going to put 0.7. Plus, what is the probability of B? Probability of B is 0.5. Not B only, but B, all of B. So it's 0.2 plus 0.5. Then how about the probability of not A and B? There is not A and B. So it's the same as B only. Not A and B. That is, there is no A and there is B. So it's the same as B only, which is 0.3. So if we add that and subtract, so this will give us 0.9. You see, that is the same as what I was saying, that when we say not A or B, it means we only restrict not A, but there's B. So it's not A or B. So it means that we take B, or we do not take A and B. So we add 0.2 and 0.3 and 0.4, which is 0.9. I believe you're following. Let's now look on the second question here. It says two events A and B are complementary. What does it mean when they say two events are complementary? They're saying A and B are complementary. What does it mean? It means the probability of A plus the probability of not A, which is actually B, is equals to 1. Exactly, we know that complementary, it's probability of A plus probability of not A. This must be equals to 1. And it means this not A, it's actually the B, according to this, because they told us A and B are mutually exclusive. Remember, we know that probability of A plus probability of not A should be equals to 1. And now they make up the entire sample space. I think we spoke about this. Also, probability of not A is 0.35. You see, they've already given this 0.35 for not A. And it means if we want to calculate for A only, because we know that this has to add up to 1, what will be the probability of A? Whereas the probability of A will be 1 minus 0.35 for complementary. So this will be 0.65. So the question says, complete the statement. Probability of A and B, this is equals to 1. Why? Because already they told us that they are complementary rule. And if the probability of A and B is equals to 1, I'm saying A plus B equals to 1, it's complementary. Events that are complementary, always they are mutually exclusive. Events that are complementary events means they're mutually exclusive. It means the probability of A and B for them, it's 0. The sum add up to 1 of those events, but the A and B becomes 0. So it says write down the value of probability of A and B. So we want A and B, they are not intersecting, 0. If they add up to 1, it means they're complementary. And since they're complementary, it means they have to be mutually exclusive. And write down the probability of B. Remember, B is the same as not A. Because they say A and B are common. So it means a probability of A plus probability of not A. Remember, if it's not A, it means yet, so it's B. So it means probability of B is the same as probability of not A, which is actually 0.35. I believe you're following. Right, let's look on the second one. A survey was conducted among 150 learners. You see, now we're talking about the number of learners in grade 10. So it means 150, that is the sample size. So we're dealing with 150 learners. So this is the sample size. It's not the probability. In grade 10 at certain school to establish how many of them owned the following device, or wanted to know how many have owned smartphones and or tablet. So there are two events, either smartphone or tablet. The result were also followed. Were as follows. 8 learners did not own either smartphone or tablet. None. 8 learners did not own smartphone or tablet. They did not own smartphone or tablet. So it means they owned other things except smartphone or tablet. 20 learners owned both smartphone and tablet, both. So this is it's tablet and smartphone. But this one, 8 learners owned either, did not own either. So it's not a smartphone and it's not a tablet. It's not. I believe you're following. Okay, let's continue. Then 48 learners owned a tablet, not tablet only, but tablets. Whereas X learners owned a smartphone. X learners owned a smartphone. X learners owned a smartphone. So the first question says, represent the information above in a Venn diagram. Now we have to draw a Venn diagram of the two. Let's now construct the Venn diagram. Remember, we're not given probabilities, we're given sample size. So it means this must add up to 150. So we're going to do this. Let's draw our Venn diagram. So just represent a set here. Means this, because it's a counting, it must add up to 150. So I'll draw the event. Let me just, okay, fine. Okay, I apologize. Okay, so we have this. Then now let me use different inks. Okay, let's say we have event A. No, it's not A here. It will be, what's going on? It will be a smartphone. So we're going to have a smartphone, and the other part will be tablet. Let me just use a different color. So let's just say this is a tablet. Right, what I will do is let's insert the values. Let's start with, okay, let's say this is the smartphone and this one is the tablet. Let's start with the intersection, where they've intersected. What did they say? They said 20 learners owned both. So it means this 20 here. So I'm gonna put 20 here. So this is for both. It's S and T at the same time. Whereas 8 did not own either. So it means it's outside. It's not smartphone and it's not tablet. It's 8. It's not either one of them. It's neither S or not T. Right. Then 48 owned a tablet. 48 owned a tablet. So it means the area for the tablet must add up to 48. If it's adding up to 48, it means we're going to say 48 minus 20. It means for a tablet only, it will be 28. For a tablet only, it would be 28. So this is where we have not smartphone and tablet, which is the same as tablet only. This is the part where we have smartphone and not tablet. Okay, I apologize. It should be smartphone, which is the same as smartphone only. Okay. Then, but now look what they said. Remember, here they said 48 learners owned a tablet, which means the area for a tablet, this space for a tablet should add up to 48. So it means from 48, we can subtract 20. This will give us 28 for tablet only. I believe you're following. Then how about for this other one, for smartphone only? Here they said X. They said X learners owned a smartphone, X of them. So it means the area for the smartphone, this must add up to X. Like what we have done here, we said from 48, so we subtracted 20. Then we got 28. So it means if this X, we're going to say from X, we subtract 20. It means the S only will be X minus 20. I believe you are following why. Because remember they said this area, the whole of S, should add up to X. So X is the total number of the smartphones, of learners who own smartphone. So we only subtract 20 from X, so it's X minus 20. So this is our Venn diagram. Then what is the next question? The next question, it says, how many learners owned only smartphone? Only smartphone. How many learners owned only smartphones? So what do you want? We want this only smartphone. It's S only, this one. This one is tablet only. So we want to get only smartphone, which is X minus 20. But we know this must add up to 1/5. So what does it mean? It means if we're answering this question. If we take X minus 20, we add it with 20, we add with 28. We add also with the 8, the neither. This must add up to 1/5. So we're solving for X. Minus 20 plus 20 would be 0. Plus 28 plus 8, this would be 36. So we have to transpose 36 to the right-hand side. So it will be 150 minus 36. This will be 140. So X is 140. But what does the question want? The question says, how many learners owned a smartphone? So let's go back to our Venn diagram. Here's our Venn diagram. Where there is X, let's put 114 to complete our Venn diagram. Let me just use a different color. So this is for a smartphone. And the other part is for okay. And the other part is for a tablet. So let's call this one a tablet. So we have a tablet and we have a smartphone. So remember I said we have now determined the value of X. We got 114. It means 114 is the learners who own the smartphone. So I want us to hide where there is X, we substitute by 114. 114 minus 20. This will give us 94. Then this will be 20. This will be 28. This will be 8. That's why if we add, so we're going to add 94 plus 20, 20 plus 28. This will give us, plus the 8, it will give us 150. But what is the question says? How many learners owned only smartphones? So we want to know the number of, not the probability, but the number of learners who owned smartphone only. Only smartphone, not the probability. So it's only 94. That's 94, it's for smartphone and not tablet, which is the same as smartphone only. For example, if I say how many learners owned tablet only, it will be 28. But if I said how many learners owned tablet, it will be 48, because it's not only. I believe you're following. Now, let's take this further. 7.2.3. It says calculate the probability. Now we're calculating probability that a learner selected at random from this group owned only smartphone. So we want the probability of owning smartphone only. Only smartphone, not just smartphone, but only smartphone. Obvious. How many here? What smartphone only? Smartphone only is just 94. So it will be 94 as the sample size, divide by, I'm saying the number of favorable outcomes. Sample size will be 150. So we divide by 150. So it's 94 divided by 150. So we can write them in decimal. 94 divided by 150. This will give us 0.63. So this is number A. So number B, it says, calculate the probability that a learner selected at random will own at most one type of a device. Let me write this. At most one type. Guys, it's very important to be able to understand words like at most, at least. So let me explain something very important here. Here they're saying at most. So we have what we call at most and at least. So if I say at most one, it means this is the same as, actually is a minimum. It's less or equals to one. At most one means it's one and below. But if I say at least, it means it will be greater or equals to one. So if I say, give me at least 1 rand, so it means you either give me a 1 rand or above. 1 rand, 2 rand or above. So here we say at most one, so it means one and below. So here we say only owned at most one type. At most one type means it's either you will own, because it says at most one, which is less or equals to one. So we'll either own smartphone only, because it's only one, or it will own tablet only. It should be at most one, or will own none. It's one or below, a one or two, or zero, none, because it says at most one. If it was, yes, it says at most one, which is less or equals to one. So anything less than one or equals to one. So it's either it's a smartphone only because it's one, or tablet only, or none, zero. Anything one or below, like less than or equals to one. It's either you own one type or none. So now, as a probability, how many, let's count the ones which were smartphone only. It's 94, one count word as a probability, plus tablet only, 28. How about none? It's 8. So we're going to divide this by 150 because we want the probability. So it would be 94 plus 28 plus 8. So this will give us 130 out of 150. And 130 out of 150, this would be 0.87. But now, let's take this. What if they said at least one type? At least one type. What they say about at least? At least means it's greater or equals to 1. How many types are here? All in all, it's 2 types. It's smartphone or tablet. So if they say at least one, means it's either it is a smartphone only, or it's a tablet only, or it's all of them, or both, because it's 1 or above, at least 1. So it means here we're going to add 94, 20, and 28, not 8. So it means it will be 94 plus 20 plus 28, which is 142 divided by 150. I mean, if it was saying at least 1, but here it was not saying at least 1, it was saying at most. So at most means it's less or equals to. So anything less than or equals to 1. So it's either it's smartphone only, or tablet only, or none, 0, none. So it means we're going to add 94, 28, and 8. I believe you're following. There's another example here. Then it says, in a random physical science experiment, A and B are 2 different events. It was found that they did not say anything about mutually exclusive. It was found that probability of A, let's write all the information. So they told us that the probability of A, it's 2 over 3. And the 2 over 5, sorry. And notice 2 over 5? 2 over 5 is the same as 0.4. And the probability of not B, it's 3 over 5. And what is 3 over 5? 3 over 8, sorry. It's 0.375. Tell me, if, okay, this is 0.375. Remember, this is not, so we know that they did not say anything about complement. We know that if you take probability of B plus probability of not B, this should add up to 1. But already we are given probability of not B. It's 3 over 8. So if we move 3 over 8 to the right-hand side, what will be the probability of B? Probability of B will be 1 minus 3 over 8, which will be 5 over 8. Complementary, because we are given not. So it means probability of B plus probability of not B, it's 1. So what is the, okay, and again, we are given probability of A or B, is this one? It's 5 over 7. So what is the first question? The first question says calculate the probability of B. Already we have calculated it, it's 5 over 8. Probability of not B is 3 over 8. So it means not B and B should add up to 1. Now, how about probability of A and B? Probability of A and B, because we're given addition rule here, A or B, we can calculate that. So we're going to say probability of A or B equals to the probability of A, addition rule, plus probability of B minus probability of A and B. Can either use this, there's no Okay, let me just write and let's do the same thing. There's no problem. So it's A and B. What do you want here? You want the probability of A and B. Okay, what is the probability of A or B? 5/7. What is the probability of A? 2/5. What is the probability of B? We just calculated it now. It's 5/8 minus the probability of A and B. We want to calculate the probability of A and B. So let's leave this as 5/7. Let's add 2/5 and 5/8. This is giving us 41/40 minus the probability of A and B. Let's move 41/40 to the left-hand side. This will give us negative 87/28. And it's a minus probability of A and B. Let's multiply both by negative or divide by. So what the probability of A and B would be 87 divided by, so this will be 0.31. 0.31. I believe you're following. Right. Then now the second question says, the next question says, hence determine whether events A and B are mutually exclusive. Remember, events are mutually exclusive if they have no A and B, they have no intersection. But if you look at this, there's A and B, the A and B, it's 0.31, and it's not 0. So it means they are not mutually exclusive. They are not mutually exclusive. Why? Because the probability of A and B, it's not a number that is equal to 0. It's not 0. They intersect. If we were to construct a Venn diagram, there will be an intersection with a probability of 0.31. So not mutually exclusive because probability of A and B, it's not 0. 0.31 is not 0. There it is. It's not 0. And the last one says the Venn diagram below represent different scenario of events A and B. Write down the probability of the shaded region for each of the following. Write down so it means we just want to check whether it's the probability of A and B or whatever. If you look at this is an intersection. So this is just A and B. Is the probability of A and B. So it's either we write it like this or we just say probability of A and B. It's just an intersection. Either one of the two. Right, how about this one? This is the same as probability of not A and not B. It's not A and not B, the shaded one. Or you can just say, because this one, this is A or B. So you can just say this is probability of A or B not. It's A or B not because it's not A or B. It's A or B not. Or you can just say A, not A and not B. So it means these two things are the same. Then how about this one? The shaded one. Look at this. This is the A and B. So this is the opposite of A and B. So it means this is where we have A and B not. It's A and B not because remember this is where we have A only. and yet this is where we have B only. So you see that it's A and B not. Why A and B not? Remember, this is A and B. So anything that is not here, it is A and B not. Same applies to this. This is A or B, this white part. So it means that other side, it's A or B not. So we can also represent it in that way. So in grade 10, what is important is to be able to know complementary rules, must be able to construct a Venn diagram, and be able to use addition rule where for A or B, and also to know the conditions for mutually exclusive events. Events that are not mutually exclusive, the probability of A and B is not zero. But if the probability of A and B is zero, it means they're mutually exclusive, ladies and gentlemen. All right. Thanks for listening. This is the end of the session. Take care. Don't forget to like, subscribe. Bye-bye.